all, my name is Zinzi Poshak-Bagai and I'll be presenting on the topic, the response of soil moisture to rainfall on sub-Antarctic Marion Island. So Marion Island is a sub-Antarctic island characterized by oceanic climate. In the last 60 years, the island experienced drastic climate change. This change will have an impact on the hydrological cycle, causing rainfall to decline in some regions. Negative effects of declining rainfall have been reported on the island, suggesting that soil moisture is responding to the changes in precipitation. Studies also suggest that the island's plants are more sensitive to changes in temperature than they are to changes in rainfall. This is a reflection that changes in rainfall have not had a biologically significant impact on soil moisture on the island. However, there is limited research highlighting the impact of soil moisture on plants. Soil moisture has a direct impact on vegetation and it determines the amount of water available for plant growth and all its other biological processes. The majority of experimental and observational studies that aim to predict the impact of changes in hydrological conditions have inadequately characterized soil moisture, even though it provides the most direct representation of water resources available for plant sustainability. Thus, this project will determine the relationship between rainfall and soil moisture on Marion Island. This, in addition, will help us determine if soil moisture plays a significant role in influencing vegetation growth. Furthermore, field quantified measurements of soil moisture are of utmost importance as they are required to make inferences about the relationship between rainfall and soil moisture. Seeing that proxy variables, for example, the topographic wetness index, may not be useful surrogates at fine spatial scales. Water movement in unsaturated soils is a non-uniform, non-linear process influenced by climatic and environmental factors such as precipitation, evaporation, vegetation, and soil properties. By vegetation, we mean vegetation type and density, and by soil properties, we mean the soil type, heterogeneity of soil texture, and porosity. Additionally, rainfall intensity and frequency play an important role in determining soil moisture in terms of infiltration and percolation processes. Studies have also shown that soil moisture varies with soil depth. So this is the saturation. One of the studies that was done in 2011 highlighted that light and intermediate rainfall events of about 5 to 15 millimeters increased soil moisture in the litter layer, but heavy rainfall greatly increased soil moisture content to a point where the surface soil layer was nearly saturated and could recharge groundwater and increase stream flow. Shreve in 1914 also found that a rain of 3.81 millimeter may have an effect on soil moisture if it falls on soil which is already moist. Furthermore, the ability of a given amount of rainfall in restoring the store of soil moisture most likely depends on the moistness of the surface soil at the time of rainfall, as well as the moistness of the lower soil. Lastly, the atmospheric conditions immediately following a rainfall event also help us to determine whether precipitation infiltrates into the soil or it is rapidly evaporated. So as you can see in this diagram, we have runoff evaporation and there's also evapotranspiration influencing soil moisture content. Studies have shown that climate change changes the hydrological cycle, causing rainfall to decline in some regions, such as sub-Antarctic Marion Island. In addition, changes in the temporal partitioning of rainfall are likely to have a huge impact on soils that have poor water holding capacity and where strong winds increase evaporation. These soils therefore require regular rainfall to replenish soil water. Such effects are experienced in the majority of higher elevation habitats of Marion Island. Thus, the declining total rainfall is likely to result in a dramatic change in the island's soil moisture regime, providing motivation to study the relationship between rainfall and soil moisture on Marion Island. Soil moisture in turn has a direct impact on vegetation and it determines the amount of water available for plant growth and all its other biological processes. Negative effects of declining rainfall have been reported on the island, suggesting the soil moisture is responding to changes in precipitation. Although evidence of declining rainfall on the island exists, its impact on soil moisture content is yet to be measured and quantified. As such, this research will aim to investigate the relationship between soil moisture and rainfall on Marion Island. The following objectives were set. So number one is to determine how microtopography affects the response of soil moisture to rainfall. By microtopography, we look at the ridge, we look at slope, we look at rocky surface, and so forth. And objective two is to determine how rainfall duration, volume, and intensity influence the response of soil moisture to rainfall. And lastly, to determine if air temperature affects soil moisture peaks after a rainfall event. So, study area. This is Marion Island. We have the sub-Antarctic region. So the sub-Antarctic region is made up of a group of islands referred to as the sub-Antarctic islands. We have the Prince Edward Islands, where we have Marion Island and the Prince Edward Island. We also have the Head and McDonald's Islands, and we have the Mercury Islands, we have the Crozet Islands, we have the Kerguelen Islands. So these islands are cool, wet, and windy. This research focuses on Marion Island, a South African volcanic island that, together with Prince Edward Island, form the Prince Edward Islands in the Indian sector of the Southern Ocean. So Marion Island is located at 46 degrees, 54 minutes south, 37 degrees, 45 minutes east, and the Prince Edward Island is at 46 degrees, 38 minutes south, and 37 degrees, 57 minutes east. Smith and Messina, in one of the articles they published in 1984, concluded that the soils in the island do not have well-differentiated profiles, and those under vegetation at lower altitudes are highly organic. The island has tundra-like vegetation and is barren of trees. It is characterized by strong westerly winds. The island has three different geologies. We have the young black lava forming rate flows between and over all the gray lava, and it is the dominant geology in the island. So the young black lava is on the left, and then we have the old gray lava, which spread from the central highland radially, and it is found on the right-hand side. All right, yes. And lastly, we have the cinder cone scoria, which are a result of many lava flows from explosive volcanoes. So they are found on the foreground, and they are covered by azorella cushion. Okay. Then we have the oceanic climate of Marion Island is exceptionally thermally stable, both at the daily and seasonal time scales. So over the last half century, the island has experienced a steady increase in mean temperature. Mean annual temperatures increased from 5.4 degrees Celsius to 6.4 degrees Celsius between the 1950s and 1990s, with the mean temperature of the 5 hottest years in the same periods increasing from 5.5 to 6.8 degrees Celsius. So as you can see on this graph, we have the annual mean temperatures increasing from the 1950s and peaking at approximately 1990s, all right? And it is continuing to increase. And right, so meteorological records show that the island's annual rainfall has dropped by 25 millimeters per year. The annual mean surface air temperatures on the island increased by 1.2 degrees Celsius between 1969 and 1999, resulting in warming in all months except the month of June. In addition, annual precipitation also declined since the mid-1990s, making the 1960s the driest of the 5 decades that precipitation has been measured at the island. All months became drier except October. So this is an illustration of the total annual precipitation on Marion Island. So as we can see, there was a decline from mid-1960s towards the year 2000. So materials and methodology. So for this research, these are some of the materials that were used to collect data, and the application RStudio will be, of course, used to study the relationships. So here we have the I button, which is used to measure temperature, and we have the logger with 5 pots of soil sensors, soil moisture sensors, and we have the application RStudio. So 5 grids of 8 meter times 20 meter were laid out in the southeast of the island. The grids were located within an area of less than 2 hectares, and they were comprising 160 contiguous 1 meter square quadrats. 2 abiotic factors were recorded for each quadrat. We had soil temperature and soil moisture. The grids were chosen in such a way that they cover the range of environmental conditions at the site, particularly focusing on mesotopography and total vascular vegetation cover. They were separated by at least 20 meters with a maximum distance of 110 between the furthest quadrats at the site, thus minimizing variation in altitudinal range, bedrock, microclimate, and species source pool. In addition, each grid had a data logger that recorded soil moisture after every 2 hours within 5 of the 160 grid quadrats. Each logger had 5 pots that connected soil moisture sensors through cables. The longest cable of the logger was 10 meters. So in the following slides, you will see this diagram. So this is a diagram, it's different diagrams, just to illustrate how the different sensors were placed on each grid and how they were connected to the logger. So in addition, the sensors were all placed at a depth of 10 centimeters. Soil moisture was measured from 6 different topography categories. So we had slope, ridge, vegetated surface, rocky surface, azarella cushion, and on some grids on wet mine. The azarella plant was destroyed when the sensor was placed in the soil. So this is logger 2, and these are the sensors that were connected to logger 2. Soil temperature was also recorded at a depth of 10 centimeters using a digital temperature probe. So in our case, we used the I buttons that were shown on materials. And the rest is logger 4 and logger 5. For data extraction, weather data was acquired from the South African Weather Services, also known as SOURCE. The weather data were recorded from the Marion Island Weather Station for the time period 2016 and 2018. So for the purpose of this research, I will use data from 2016 May until the end of 2017. The data contained hourly air temperature and rainfall data, which I will then convert to 2-hour readings so that they match that of the soil moisture sensor recorded at the island from May 2016. I will then record for each rainfall event the duration between the rainfall peak and the soil moisture peak per logger sensor, as well as the rainfall volume. For statistical analysis, general linear models will be used to demonstrate the relationships and trends for each weather element, focusing on temperature and rainfall, particularly rainfall, against soil moisture on the island. This will be performed in the application RStudio. Furthermore, the next slide will demonstrate possible linear equations that will be used to investigate my objectives. So we have equation 1, we have change in soil moisture as a function of rainfall plus rainfall duration plus topography plus air temperature plus interaction plus 1 over cell ID. So change in soil moisture basically is will be the soil moisture content before a rainfall event, and we have soil moisture content after a rainfall event. And then for equation 2, we have time for soil moisture to rise, where we have rainfall volume as a function of rainfall volume, rainfall duration, plus topography, air temperature, interaction, and 1 over cell ID. So the time for soil moisture rise, it will be the time that it takes soil moisture to rise after a rainfall event. Possible interactions for both equations are rainfall volume to rainfall duration, rainfall volume to air temperature, rainfall duration to air temperature. Duration will be determined by the total hours it has rained for one rainfall event. The rainfall data used in this equation will be that acquired as secondary data from South African Weather Services. In addition, a rainfall event will be quantified by rain for more than 3 hours, followed by a dry period of more than 3 hours without rain. And this is a Gantt table, and roughly these are roughly dates that I will, or a schedule that I will use so as to conduct my research, and just to make sure that I'm on track with everything, the analysis and the results, and submitting reports to my supervisor. Thank you very much.